Question 25. A baseball diamond is a square with side 90 feet. A batter hits the ball and runs towards first base with a speed of 24 feet per second. At what rate is his distance from second base decreasing when he is halfway to first base? So the first thing we're going to do is we're going to draw another square. And so our runner, is right here, and he has 45 feet left to get to first. Then we know that from first to second is 90 feet, and then we can draw a right triangle with side length D. We're also going to call this 45-foot side X. And so now we're trying to find the rate at which D is decreasing. So we can use Pythagorean Theorem to do D squared is equal to 90 squared plus X squared. We also know that dx over dt is equal to 24 feet per second. And now we can take the derivative with respect to time of both sides to get 2d times dd over dt is equal to 2x dx over dt. We then must find this d side over here. And so in order to do that, we'll just use the Pythagorean Theorem, which is d is equal to the square root of 90 squared plus 45 squared. And when we plug that into the calculator, we get an answer of d is equal to 45 square roots of 5. And we know that x is also equal to 45 feet. So now we just plug these into this equation in order to start solving for dd over dt. So we're going to have 2 times 45 square roots of 5 dd dt is equal to 2 times 45. And since the question is asking for decreasing, we can make that 24 a negative 24. And so now we just have to divide this 2 square roots of 45 to the other side, and we'll be left with our dd over dt. So we have d over dt is equal to 90 times negative 24 over over 90 square roots of 5. And so these 90s cancel out, and we are left with the answer of negative 24 over the square root of 5. And now for units, we have feet times feet per second over feet. So we just cancel out those feet, and we're left with our final units of feet per second. And now for the second part of the question, it asks for at what rate is his distance from third base increasing at the same moment. So we'll draw our same square, and we still know that he's at 45 feet to first base, and that is still our x, but now our d is going to be from third base over, and that will be our new d. And so we're going to solve this question the same way we did this one, and so we'll take d squared is equal to 90 squared plus x squared. We'll take the derivative with respect to time of both sides, and we'll be left with 2d times dd over dt is equal to 2x times dx over dt. And since this triangle and this triangle are the same triangles, we know that d is also still 45 square roots of 5, and so we're left with 2 45 square roots of 5 dd dt is equal to 90 dx dt. All I did to get 90 is I plugged 45 in for x and just multiplied it by 2. And so now we just have to simplify this for dd dt, and we're left with dd dt is equal to 90 dx dt, which we know is 24, and since it's increasing, it is now a positive 24. And then it's still over 90 square roots of 5. Our 90s cancel out, so we're left with the final answer of 24 over square roots of 5. And since all of our units are the same, we still are in feet per second.